Well, hello again. This is Ed Davis with Wings of Grace. We're continuing in our lessons in section or chapter 1 of the Gleim study book. Today it's lesson 1.10, dealing with load factors. So let's go ahead and jump right into what we're looking at here. We're going to look at a few just basic understandings first. First of all, the load factor is measured in G units, and in straight and level flight has a load factor of 1, and that G stands for measures of gravity. So it's just like sitting in your chair. You're feeling the normal 1 G on your body from gravity when you're sitting in a chair. In the same way, when you're sitting in an airplane and flying in normal straight flight, you're experiencing 1 G. As the airplane increases, as we continuing on with this, is the load limits on a normal category airplane, the Cessna 172s that we do for training, depending on the weight that they're at, will either be in a normal or utility category aircraft. And the commuter aircraft and such that you fly, that you might fly in, like a Saab SF-240 on Spirit or something like that, is in a commuter class. And those airplanes, they are rated for negative 1.52 Gs and positive 3.8 Gs. So a negative G is like if you're on a roller coaster and you go over a hump and you feel that lift in your seat. That is negative Gs. And the commuter and normal class airplanes are rated for negative 1.52 Gs and positive 3.8 Gs, so almost 4 times your normal weight being pressed down on you. And then for utility class aircraft, that goes up to negative 1.76 Gs and a positive 4.4 Gs. The airplane's a little bit lighter, and it's able to pull a little bit more G's in each direction. Now, how do you pull G's in the airplane? Well, that comes from a number of different things, but basically G's are caused by acceleration in any direction. If you're in your car and you make a really sharp turn, you feel lateral G's. It's pushing you to the outside of the turn. On the other hand, if you are in a steep turn in an airplane, the pressure pushes straight down on you. And what we see with that is in this diagram, you see that as the bank angle increases, the load factor increases. The wings have to carry the weight of the airplane, plus the centrifugal force. The turns increase the load factor. So what you see in that is as the airplane turns and turns over into a bank angle here, as it turns over, you have the load factor going straight down into the through the center of the airplane. Centrifugal force is being pushed out, the weight increases, and then you take those two vectors and you see an increase in the load factor on the airplane right there, and that's where you see the G's being exerted on the airplane. So as you're continuing looking at the charts here, the next one, this gives you a chart looking at exactly how much load is going on the airplane for any particular bank angle. And as the bank angle increases, you can see that the load factor on the airplane, when you have 0 degrees of bank, you have 1 G. At 10 degrees of bank, it's 1.015 Gs. At 30 degrees of bank, 1.1. Notice at 60 degrees of bank, you're pulling twice the weight, your normal weight. You're carrying 2 Gs on that. So if you take that and multiply it out, looking at the questions here, the load factor weight of an airplane that weighs 2,300 pounds and 60 degrees of bank, the airplane's going to weigh twice as much. That's 4,600 pounds. understand, this is not like a chill factor in temperature, where it might be one temperature but it feels like something else because of humidity. The airplane actually weighs 460 pounds, 4,600 pounds. If you were able to put a scale under that airplane, it would measure out 4,600 pounds. If you weigh 150 pounds and you're pulling 2 Gs, you really weigh 300 pounds. You really weigh 300 pounds. The load factor weight for an airplane weighing 3,300 pounds at 30 degrees of bank, you see 30 degrees of bank is 1.154. So if you multiply that out, that gives you a weight of 3,950 pounds. The load factor weight for an airplane weighing 4,500 pounds and 45 degrees of bank, and you multiply that out, that gives you 6,750 pounds that the airplane weighs. Now, in addition to bank angles, there's other things, like I said, that can cause acceleration on the airplane. Gust, rough air, abrupt control inputs. All of these things put an acceleration and therefore G-loading on the plane. Therefore, if you're in a gust and you hit a downdraft, when you fall, you feel that negative G for a second, but then when you hit the bottom of it, you feel that positive G, and that can actually be a very dangerous situation. We'll talk about that in just a moment here. But as we continue on with the questions here, the amount of excess load that can be imposed on an airplane wing depends on the speed of the aircraft. If you remember a few earlier lessons, we were looking at the airspeed indicator, and there's a yellow arc up in that, and that's in the higher speeds. And the next marking after the yellow arc is that red line, V&E, that velocity that you're never to exceed. And in that yellow arc, it's a cautionary area. It's a zone in which you only want to fly in smooth air. You don't want to do any abrupt control inputs, because you could over-G the airplane. Because of those higher speeds, the airplane will accelerate more when it is moved off of its course, and therefore a higher G loading. Let's see, at low air speeds, very little excess lift is available, so very little excess load can be imposed, and the airplane will just stall first, which that's true. There's less lift available to load to carry the weight, therefore the airplane will most likely stall. But the reality is, because the airplane's going slower, less acceleration goes on the airplane and less G loading will occur there. At high speeds, the wings lifting capacity is higher, so excess load can quickly exceed safety limits and cause structural damage. And you have two things going on there. Number one, the speed of the airplane gives you more acceleration, but also because the wing can create more lift, it's going to carry that load, and you could exceed the load limits on the airplane. Because of that, there is a speed that we want to be aware of, and we'll look at it later on in some of the training, and it's called the maneuvering speed. In fact, we'll look at it in the next lesson. Basically what we want to understand is there's a particular speed that the manufacturer has developed, that as long as we're at that speed or less, we can do complete full deflection and abrupt control inputs, and the airplane will stall before it will damage the airplane. But understand that load, G loading, has basically two factors: bank angle and speed. The steeper the bank angle, and when you're turning, the higher the G load on the airplane, and the higher the speed the airplane goes, the higher the load generating capacity the airplane has. So we always want to make sure that when we're maneuvering, when we're doing training maneuvers where we might have to put abrupt control inputs, that we are below maneuvering speed, and when we're in rough air, we want to be at or below that maneuvering speed. So that is the lecture on load factor.